Okay, today's day 9 of logs, and today is the E day. E is 2.718. It's a special number. It's one of the only functions where you can take its, gosh, you're going to learn this in calculus. I know there's something special about its derivative. I think its derivative is equal to itself. Anyway, it's something really special when you hit calculus. For right now, we'll just say that it is a number that occurs in nature. That's 2.718 number, and it's used in continuous interest rates. I don't know if you remember this, P e to the r times t. That was the principal amount. Like say you have $5,000 to invest, then this e was 2.718, and then it was the rate and the time multiplied in its exponent. That was an example of where we used e. Well, now we're doing logs with the base of e. So here's the confusing thing. It's really not that confusing at all. If every time you see E, you just think, oh, 2.7. It's about 2.7. So that's log base 2.7 of 2.7. Do you get how the bases are the same now? And therefore, what's the answer of that one? 1. Okay. And here's the other thing that can be confusing about it. Let's say it's a more simple one. Log base E of 5. There's a button for that on the calculator. And it's not the normal log. It's what? ln. ln 5. You sit ln 5 and you get the answer. And what you just did was a log base E, log base 2.718. Okay. What was that, by the way? Okay. Raise your hand if you had about 1.6 on that. Okay, good. Then, here's how you'll see them written in problems. Let's say that was your question on the test. That's a pretty easy one, actually. As long as you know how to put this in the calculator. We just figured out that 2 seconds ago. And then you'd add 2 to it, and then that equals 2x. And you just solve for x, you'd have to just divide by 2. You'd have this decimal, and then you divide it by 2. All right? So ln, anytime you see it, please replace it with a log base E. Because when I show you this, for instance, it looks really confusing. But if you do what I suggested, wherever you see ln, write log base E, do you get this will be log base E of E to the 7th? And now it becomes crystal clear that the bases are the same. And therefore the answer must be what? 7. Okay. So whenever you see ln, write the base. It's a good rule of thumb, too, if it's no base on this one. Log 9. People get confused on like how to rewrite this. How are you supposed to rewrite that? There's no base, but there is a base. So always write the base. It's my advice. So if it doesn't say the base, well, then you know it's a 10. 10. Then you can say that means 10 to the x. Oopsie. 10 to the x equals 9. All right, so I want you to try a rewrite, just like I just said, ln of x is equal to 3. If you follow my advice I just gave you, the rewrite on this will be easy. Just got a decent short-term memory. You can tell me, what was I supposed to do on this? Remember what to do? Yes, rewrite this as log base E. Now, why did you do that? Now you can see how to rewrite it. I like that. So this is E to the 3rd equals x. E to the 3rd equals x. Well, what's this E to the 3rd? There's a button on your calculator for E. If you want to know exactly what E is, it's right above the divide key. Go ahead and use your calculator and get the decimal for it. It's 2.718 to the 3rd. Final answer would be what? Okay. So what have you learned so far? Just that there's a new kind of base. That base is E. And if you ever see it written as ln, you should write it as log base E. All right, I'll give you another example. Do you remember this pattern? The bases are the same, aren't they? The base of, with this exponent on it, and the base of this log are the same, and therefore the answer is already there, and the answer is what? 12. So if you know that, then what's this? E to the ln 4. How did people know it was 4 so fast? They changed the ln for a what? Log base e, and then you see, oh, those are the same. So the answer is just 4. All right, so that's the best thing you can do with those log base e's, is just rewrite them as, instead of ln's, write log base e. Okay, let's get to a few questions. How did e develop? Well, e can be gotten through this little formula. It's 1 over 0 factorial plus 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial. In case you forgot what factorials are, they're little multiplies where you go, let's, for instance, 3 factorial means 3 times 2 times 1. And it just, 4 factorial means 4 times 3 times 2 times 1. So if you take, oh, by the way, 0 factorial, it's weird. It's defined as equal to 1. So this would be 1 over 1 plus 1 over 1 plus, you get why it's 2.718. Get out of the first two just equal to 1s in different ways. And then the next one's 1 over 2 times 1, which is really 1/2. Okay, so 1 plus 1, it's 2, plus a half, 2.5. But now I got a little bit more. That plus 1 over 3 times 2, which is 1/6, plus 1 over 4 times 3 times 2. Anyway, that's where you can calculate e exactly, is if you keep doing that. But notice the dot, dot, dot. That means forever. You haven't done limits yet, but this is a limit notation, which means you keep doing this where you put in different numbers for n, and you keep doing it over and over and over, and you just keep adding them forever. All right, moving on. So if e is about 2.718, don't be surprised whenever you see, you're never going to see it written this way. You're going to have to write it that way. How would you see it written? ln. Okay, you're going to write log base e because it's so much easier to use when you have a base. Because what do you need the base for? So you can do rewrites. All right, so here we go. Log base e means ln x. Next slide. Since again, it's just best tip of the day. Like if this is the thing, if you not get nothing else out of today, whenever you see this, you put that. And then you'll go, wait a minute, those are the same. So that's the answer. Okay, so how am I supposed to graph these with e's in them? Well, if you had a calculator, you just type it. But you don't want to have a calculator for this next test. So how are you supposed to do a log graph? Well, first of all, XY chart is your best way to do every graph. But you got to choose wisely. Okay, like, do you get if I put in a 7 here, that nobody in the room is going to probably be able to do log base 2 of 7 in their head without a calculator? So don't pick 7. What would be a good thing to pick? 1. If you won the argument, you get 0. So 1 comma 0, good. And put in a 2, isn't that a good choice? Log base 2 of 2, what's that? So 2 gives me a 1 over 2 up 1. My alignment's off here a little bit, I apologize. And then I agree, 4 would be a good choice. And that would be what? 2. So over 4 up 2. And look at that. It's going like that. It looks kind of like the square root function. But do you remember this? The log goes down like this too, and it gets closer and closer to, let me put in an asymptote that's big and gaudy and easy to see. Remember that the asymptotes run right at 0. So unless this thing got shifted, that's the parent graph. That's what they all kind of look like. So how is log 3 any different? The bigger the base, the tighter the turn. So basically it still goes through here. Why? Because that's where x is 1, and you won the argument. No matter what the base is, you get what? 0. That's why it'll always hit here to start with. Now you can shift it from there if you want by like doing +1 or like throw in a -3 on the inside. You can make it move. but it'll always start there. And then it just has a sharper turn. It turns a little sharper than this one did. Okay. And if it was log like this, that means log base 10. And that means even sharper turn. And it like almost touches the x-axis the whole way. It's like a super sharp turn. All right. Well, how about this ln thing? My opinion, ln and log base e, which are the exact same thing. Do you get how these are identical to each other? I was trying to make a point here. Then I would recommend you make an XY chart again and choose wisely. So I think it's easier to do this one. Remember me saying whenever you have ln to not do ln, instead do log base e. So everybody try to make an XY chart with choose wisely. There's only a couple numbers that are going to go in here nicely. Hint, E is about 2.718. No calculators. You wouldn't have a calculator on the test. So give me something to stick in for X that would work nicely. 2.718. Do you expect that I'm going to be looking to see that you would put your dot on exactly 2.718? Of course not. But it's about 2.7, which is just a little less than 3, okay? But if I put that in here, it's supposed to be the same as this. And if the bases are the same, what's the answer? 1. Good. What's something else we could choose wisely for X? If you won the argument, you get nothing. Good. 1, 0 should be on my graph. And the last thing is, I actually agree with you to put in 0. At first I was going to say, no, you can't have a 0 there. But do you remember when you put a 0 in and you make that parenthesis part be 0? Do you remember that you're finding the asymptote? When that's equal to 0, that's where the asymptote is. We had a problem like that yesterday on yesterday's homework or on the Schoology quiz. If this part is 0, if the argument is 0, then you found the asymptote. And pause for a second. It's just a funny math word that means that dotted line that you run along and never touch. So the asymptote line is at 0. So there's my asymptote line. And now I was off just slightly. Let's see if I can move it just a titch. Okay, good enough. It's bothering me. Gotta try to fix it. There we go. Good. Okay. And then at 1, 0, I got to put a dot. And at 2.78, I know you don't know exactly where that is. It's about 3, 1. There's a dot, and so then it goes like this. And I like to always have at least 2 points on your logs. At least 2. If you can get 3 in, awesome. But in this case, especially with E, it's really tough to get any more than 2. Because you got to do weird things like put in E squared. What the heck is E squared? 2.718 times 2.718. Okay, 7.3, fine, but you got a calculator and you won't on the test. So anyway, 2 points on this is probably good enough. So there's what log base E looks like. It's just a different base. What's it about? It's log base 3 about. 2.7 is about 3, right? So it's pretty much like log 3. Do you get how this and this look very similar to each other? This one and this one, they're pretty much the same thing. Why? Because one's log 2.7 and one's log 3. All right. Kids always find this to be one of the toughest parts when you're supposed to graph with these. Let me just go back to that graph thing for just a second. So if I said graph log, let me make it 3, log base E of X minus 1. All I need is 2 points and the asymptote. See if you can find 2 points in the asymptote. If I asked you to graph this log base E, which would have started as an ln, once you're more used to it, I would do that to you. But so choose wisely. You want this little block right here to come out to a nice number. So you can times it by 3 and then subtract 1. Give me an X that you could put in That would work pretty nice. Just a 2 wouldn't work so nice. Nope. I know you're thinking, you go, we can't leave the green box till we're done with the green box. Okay? X being 1 is a good choice. Why? Because you won the argument, and therefore that whole green box is equal to 0. Does that mean the whole thing is equal to 0? No. Just the green box is equal to 0. So 3 times 0 is 0. Minus 1 is negative 1. Good. We found 1 point on our graph. Now give me the only other thing that would work nice. Yeah, E, or 2.718. Some kids are going to write E. Some kids are going to write 2.718. It's the same thing. One's rounded a little bit, I guess. So if I put in an E right here, do you get that log base E of E is what? When these are the same, what's the answer? 1. 1 here. So all of that's 1 times 3 is 3. Minus 1 is 2. E goes with 2. How am I supposed to graph E? Well, it's about 2.7. So you're going to go over about 2.7 and then up 2. So here's 2.7. It's pretty close to 3. Up 2. There's a dot. And 1, negative 1. Over 1, down 1. There's a dot. And then where's the asymptote? The asymptote means the argument was made equal to 0. They had no argument. Okay, so there's a 0 here. They put in a 0 for x. It makes the asymptote line. But remember, the asymptote line got moved in this case. Do you get that the asymptote line got moved 1 to the right? So the asymptote line that would have normally been at 0. No. Wait a minute. That thing on the right is not up. This is up or down, not left and right. My bad. That's going to move up and down. So is the asymptote line going to move when I move the thing up and down? No. So the asymptote line starts at 0 and stays at 0. My bad. I was thinking that it got shifted, but it didn't. What's 3 times 0? Okay. So anyway, the asymptote line won't move at all. If I move it up and down, feel free to if you want to, but it's not going to actually move. Okay, so final answer. There is my graph. I got a couple of points. I know where the asymptote is. That's how you graph these. Choose wisely. There's only a couple things that will work nicely. Making the argument 0 tells you where the asymptote is. Making the argument 1, you've won the argument, you get nothing. And the last one is make the argument E, because if you have an E here and an E here, it works out nice. That was this one. Yes? We're pretty much done learning the new stuff, but let me finish these slides, and then you'll have learned everything you need to know for the test on Friday. All right. Yes, sir. You will have to do everything. Yes, being able to write equations is another option. You wouldn't have to write. If I gave you a log graph, you wouldn't have to figure out, here's the equation for that, because they're so complicated because of their decimals and stuff. But you would definitely have to be able to graph an equation that I give you. Okay, so this one, if it doesn't come to you right away, then just change ln to what? Log base E, and then all of a sudden it's log base E of E to the 15th. Now what's the answer? 15. So easy once you have figured out to write ln as log base E. What was this answer? 2. Because it's E to the log base E of 2, and if these bases are the same, that's the answer. All right. So how it says, remember the change of base formula for base 10? Basically what they're saying is, do you get we used to write in log 17 over log 3? And remember me telling you before that you could use any base you want? So what's the base we're introducing today? E. So you could use log base E. So if you did that, it would give you the same exact answer as if you said log 17 over log 3. So ln 17 over ln 3 would give you the same answer as this, which is the same as log 17 over log 3. And just to clarify, though, that does not mean ln 17 is the same as log 17. They have different bases. But if you use a bigger base here and a bigger base here, it cancels each other out because you're dividing. So basically, you can use the ln key if you want when you're putting this in the calculator, ln 17 over ln 3. All right, so this is a review problem with PERT. Remember me mentioning that earlier? PE to the RT. Well, why would we need a log for this? Because, watch what happens. 5,000 goes in for the P. 5,000 times, green on green's not great, so E to the R, did they tell me the interest rate? Yep, 0.09 is the rate. And then T is the time, and it doesn't tell me the time. How long will it take? So I put a T there. A lot of people get confused because they think there's two variables, Mr. Server, an E and a T. False. Is E a variable? No, it's a number. So therefore, this only has one variable, and it has an X in the exponent. So then the question becomes, how long will it take to double your money? Remember, this is the start value. What goes over here? 10,000. The end value is double the money. So now, to solve this, you would start by dividing by 5,000 to get this clump alone. And 10,000 divided by 5,000 works out to 2 perfectly. Equals E to the 0.09t. How do you use a log to solve this? Well, you got to rewrite it. Log base what? Think about it. Log base E. And then you jump to the other side of 2. See, it goes over here, and then it has to go back over there. Equals 0.09 t. We divided by 5,000. Divided by, divided by 5,000. And then 10,000 divided by 5,000 is where I got the 2. Okay? So then this was a rewrite, log base E of 2 equal 0.09t. And then I'm pretty much done. If I only had a calculator, I could get that decimal and it'd be super easy. If I don't have a calculator, then I leave my answer like this and say divided by 0.09 on both sides. And you could leave it that way. If we didn't allow a calculator, that would be the answer. Log base E of 2 divided by 0.09. Or if you want to be fancy schmancy, ln 2 over 0.09. Because ln 2 is the same thing as log base E. All right, I think you've learned everything that you need to know. So let's get to the worksheet for today. It is worksheet 9. The natural logs, terrible, terrible joke. I used to be a volunteer in the National Park Service. Like they had this patch. You were a VIP, the volunteer in park. So I would be the VIP. And what they would do basically for me, they needed boats moved around. There was a national park way up north called Voyageurs National Park, and they let me move boats around. It was kind of fun. So I'd get in this boat and drive it over here, and then get in that boat and drive it over there. And so, all right. Here, worksheet number 9. Let's open it up and get it started together. I'll pause for a second while we do that. Okay, so here's the worksheet. It is the Natural Logs and Applications worksheet. I don't want the key, though. So this one. There we go. And I'm going to download that quick. And it's really small. I'm going to make it bigger here. Okay. These are all going to go pretty fast with the calculator. The top part says with a calculator. Bottom says without a calculator. When it's without a calculator, my advice to you was whenever you see ln, rewrite it as what? Log base E. So this will be log base E of E to the pi. Kind of weird, but if the bases are the same, Pi is the answer. Good. All right. Whenever you see ln, if you learn nothing else today, wherever you see ln, write log base e. Okay, there are some real world problems here, so if they give you the x number, you'd stick it in there. If they give you the f of x, like the y value, that goes at the beginning. I know it's off the screen, but anyway, just stick the numbers in the right spot in your word problems. And I feel like it's a little long, so why don't we skip 5 and 7. Why don't you skip 5 and 7 today? And that's all I got for you for today.